Hello everyone, so today the Memento pattern. So this pattern allows you to save and restore previous states of an object. So it's very elegant and powerful. So it's a bit of an advanced design pattern, so don't hesitate to pause the video if you need, and I encourage you to try it by yourself step by step as I do, so then you can fully understand that pattern. It has a lot of moving parts, so I'll start the video by just showing you the different components in place and how they interact with each other. Then I'll implement it in Go. I'll show you an example of it, and then as usual I'll discuss with you pros and cons of that pattern. So if you enjoyed the video, like and subscribe, and leave me a comment if you have any question, so then I understand that you enjoy this kind of content and I can do more. Alright, so we have four components for that pattern. We have obviously our business logic, which is the state that we want to save and restore, the originator, the memento, and the caretaker. Right, so the originator will be able to get and set your business logic, and then your originator acts as a bridge with the memento as well. So the originator can save and restore a memento. So memento will be basically a wrapper of your business logic that your originator can create and restore. Then the memento itself is just an encapsulation of your business logic. Okay, and then lastly, you have something called a caretaker. So a caretaker is just a manager for your memories, for your snapshots. So your caretaker can has understanding of mementos only. So it's capable of storing them and retrieve the one you need. Alright, let's begin. So as usual, we will create a module for that design pattern. So we will call it the Memento package. We'll create a main application. Then we need a few sub-modules because it's a quite more filled up pattern. So let's just create a simple human package with a few simple structs, so then we can have a good understanding of how this pattern works. Okay, so on the left you have the main program, and then on the right we have our human package. So just starting to create a human struct with some, let's say, some life points, which is an int, and then let's just create a constructor for it. I'm just using the ID shortcut, and then, as you know, I like to create a simple display method, so then we can see how many life points your human has, because notice on line 6 life points is a private field because of the lowercase l. So it's not gonna be accessible from your main program. So it's not gonna be accessible by your memento, originator, or caretaker. Okay, so the display function, as you can see, is just a log function. So as usual, let's just try it out. So here, just a quick extra, you can just declare in your main program a function init and set any custom logging or any custom telemetry you need. So here I'm just adding a line break. Right, so you can see on line 14, I'm just declaring a human, and I just modify the constructor to just give it by default 100 points, 100 life points. There you can see life points 100. So all good, really easy struct with a field and a receiver method with display. So now let's make things interesting. So we're just gonna create receiver method called damage, so you can just take out some life points out of a human. So then we can have a mutable function, so then you can see how it's gonna be maintained with the Memento pattern. Right, so here just a quick example of how you can use damage. So we damage with 50 points, so then if I display, I should see 50 points. There you go. So far so good. Okay, so now let's create our originator that I showed you at the beginning of the video. So we will just create a submodule called originator. Then we will create a file originator.go. Okay, so that's another package. So we can create, so this originator will take care of human, so we can just call it human originator, and it will hold a human. So you can see that human is coming from another package. Okay. So that originator, if you remember, it's gonna be able to create Memento and restore Memento. So first we're gonna create that save method to create a Memento, that receiver method. So we haven't created a Memento yet, so let's do that as well. So back to the module Memento, we will create another submodule called Memento, and we will create our Memento there. So memento.go. So you can see the package is now Memento. So let's just declare an interface. Let's work with an interface. So a Memento has the capability to restore a state, and just the restore interface here just throws back an interface as well, so then it can be reusable. And now we can have the human Memento implementation. So the human Memento will be able to encapsulate a human as well. So very straightforward. So just using ID shortcuts to implement the Memento interface, and that restore method will be able to return you the human stored in the Memento. So not human.newHuman, but the memento.human. There you go. Okay, so if we go back to our originator, so we have now a Memento interface that we can use. So our originator will be able to return a Memento. Okay, so I'm just gonna organize the idea a little bit better so it's easy to understand. So that your originator save Memento will simply return a Memento. So let's just create a constructor for that Memento. So using ID shortcut here. So then you can just invoke that constructor method. you're constructing a snapshot, you're constructing a memory of it. And you can see that to build a memento, you need a human, so it's simply gonna be the human stored in your the current human stored in your originator. Okay, so let's provide a constructor for our human originator. So id shortcut. Let's try that. Originator. Then you can see we have a package clash because I'm trying to name my variable originator, but the package itself is called originator. I will be lazy and just call it O. So originator and the new constructor we just created, and you can see my ID is complaining because we are trying to pass a pointer human instead of a human. So just need to dereference that pointer. And this is our save method here in action. So line 21 is returning a memento because the originator is responsible to create memento itself. And so we have a memento, and with my human memento I can restore it. So let's see that in action. So you can see if I assign m to that memento and do m restore, in principle the human contained in the memento should be the one from the originator. So two objects storing themselves human, so then we can just explore them. So if I do save.display, you can see that the memento 23rd. Alright, just cleaning a bit. So you can say it's the same human there, which is restored. Okay, so step by step, simple. Always test bit by bit what you're doing, so then you can detect errors early on. Right, so here I'm putting back the damage to the human, and I'm gonna try to restore it. So now the originator need another method, and it needs to be able to restore itself the human that it's encapsulating. So for that, it's gonna take a memento. So if you remember the diagram I drew earlier, the originator knows about mementos and knows about human. So the restore method is quite simple. From a memento, it's gonna change its human, so the field 9. Okay, so here you can see I've got just a function problem because my function is not returning anything, it's just assigning to the human to the field. So then my originator.human and restoring the memento it's receiving. Okay, let's go slightly slower. So we have a human, it got damaged 50 points, and then we built an originator and we made a memento of it. So the human in the originator has 50 life points so far. So my memory at line 21 is 50 points, 50 life points. So line 23, we take 25 more damage. Okay, so M is not used, so it's gonna complain, as you know. So we will just not do anything with it. Okay, life point 25 as expected. So now we want to try our restore function. from the originator. So I have a single originator, so originator.restore, and then the memento, the memory we created on line 21. So then I need a way to get my human, right? So you can see here I'm stuck because I don't have any way to access my human, which is a private field. So to remediate to that, we can create accesses. So the one we want now is getter. So we simply gonna call it get. And because my originator in that case is a implementation of our originator, it's okay to return just a human for simplicity, or you could throw back an interface and cast it after, but just for the simplicity of this exercise, let's just return a human. So you can see on the left side that I'm getting my human. So let's assign it to a variable human, call it in h1, and if we display it, it should be 50 points because we are restoring a memory. There you go. So far so good. So we have a human, we are damaging it, we're making a copy of it, damaging it again, but then restoring the memory. Okay, so if it's a bit complicated for you at that point, go back to the diagram that I drew at the beginning of the video. It might help you to understand where we are in the pattern. So there's a few pieces that we are missing, so we can see how to get a human from the originator, but it would be interesting to be able to set the human as well. So there you go. So as an input you have a human, it's not returning anything, and we're calling it set. So we're just setting the field human from an originator to the human you're receiving. Okay, as usual, I like to try things step by step, so let's try to set the originator. For instance, after it took 25 damages, so if we set, so here you can see it's complaining that it's receiving a pointer, so we can just dereference. And then straight after, if we do get, so we're gonna call it h0 to differentiate from h1, and you see that my h0 in the originator is indeed 25, so same as the snapshot, same as the display we are doing on line 24. Let's go further now. So we have the memento, the originator, and the human itself. And if you remember the diagram I drew earlier, we need a caretaker. So the caretaker is only taking care of mementos. So it makes sense to have it in the memento package. So a caretaker has a field called content, and it's a slice of mementos. It has the ability to store a memento in that content slice. So simply, when this store memento is invoked, we're just gonna append that memento to the content. And it has a second method called last. So what it does, it's really straightforward. So the last memento who got into that slice will be ejected from the slice and returned. So we will just start by putting safety. So if your slice content is empty, we will just return you an error. So very classic Go pattern with that tuple value and then an error. So in that case, if the slice is empty, we are not returning any memento, but we are returning you an error that you can check if you're using that method last. And then if that's not empty, we can just get the index of the last memento, which is just the length of the content slice minus 1, because in Golang slices start with index 0, and then we can just get the memento by querying it on the slice. Then we can just remove that last index, as you can see on line 21, and just return simply the memento that we queried. So if that data structure is familiar to you, it's the stack that we saw last week. So you can see how useful it is. So your caretaker is actually a stack. So last in will be the first out. So the last memento who got in will be the first one that we will retrieve from that last function. Before continuing, let's just study a bit. So you can see that Memento has an interface. So let's build an interface as well for the originator. So an originator interface has two methods, two mandatory methods: save a memento, create a memento, and then restore a memento. Get and set are just non-generic for our function, so you could do the work and generify them and put them in the interface, but we're not gonna do that. Okay, so just a slightly change of the human originator constructor. So instead of providing a human, it will create a human itself. Okay, so lastly, we will just create a constructor for our caretaker as well. So that constructor will take care for you the creation of that slice with a capacity of 0. Okay, so let's put all of that together. So we need a caretaker, so we are invoking that constructor. Yeah, let's just starting from scratch. So we have a caretaker, we have an originator. No need to create a human, the constructor will do it for you. And then let's just try out our store function. So we need a memento. So we create memento by invoking originator.save. So let's put some command to organize a bit that main function. So you have the init first, then our first memento. Okay, so you can see that it's straightforward. So an originator create a memento, then the caretaker can store that memento for you. So caretaker is a memento manager. If we inspect what's in the originator at that moment, we should have a human with full health. There you go. So if with that human 0, we damage it a little bit, so 75, for instance, not a little bit actually, so it's only 25 health one left. So let's create a memory of that human. So originator.save to create a memory. Just before that we can set the originator to human 0, and then store that memento that we just created, memento 1. Okay. So if we damage it a bit more, our first human, so it should have negative health point, minus 25. So in a video game, it would mean that you're dead, so you might want to restore your last save, for instance. So far in your caretaker, you can see that we made one save at line 21 and the second save at line 30. So if we ask our caretaker to give us back the last memory, so if you remember, it's on the right, your last function gives you a memento and an error. So then it would be last memento and an error. So it's good practice to just check that there's nothing in your error. So we will just log our error for the sake of simplicity here. So then with our originator, we can restore that memory that the caretaker held for us. If we just inspect what's been held by the originator now, if we call it h1, so 25, and it works as intended because 25 was the memory from Memento 1 after the human got 75 damages. So we just restored it. We just restored the human in the originator to that. I'm just gonna display it because I didn't display it. So there you can see 175 damage to 25. We made a memory and then we put 50 damage, so it went down to 25. And then we restored it to the memory 1, which was 25. We're gonna rinse and repeat, so this time I'm not gonna check the error. And then we're gonna restore the last memento. So assigning h2 to the human stored in originator, and all back to 100. So you can see that the caretaker stack data structure is working as intended. So the first which went out was memento 1, and then the second one was the last item in the caretaker, which was memento 0. Okay, a little bit of discussion on that pattern as usual. So let's start with the good things. So first, to clean code and solid principles. Obviously, you saw that things are quite small, methods are concise, you are using interfaces, they have single responsibility, they are quite easily scalable, and you can implement different version of your memento or your originator and so on and so on. And you can even generify the getter and setter that we saw. So globally it's quite easy to maintain this kind of code. So the third one, easy to test, goes naturally with it because things are clearly separated, encapsulated. It's gonna be a walk in the park to test this kind of code. Now the bad things. So you saw that the human we designed just had one field, which was her life points. So the caretaker, if you're not careful, and if your caretaker can save like hundreds and hundreds of copies of that human, you might have a RAM problem, a memory problem. So to mitigate that, maybe your caretaker can be something more complicated than a static data structure, just talking to a database if it's an absolute need to save all those snapshots, or your caretaker can simply have a capacity. So if your caretaker is out of capacity, you will not let your client making other copies of your human, for instance. Your caretaker won't accept any more mementos. So that's one way to mitigate it. The second point was be very careful when you use pointers with Go. So be very careful where I put pointers and where I did not put pointers, because if you're working in another language, you might take copies of objects, but you might not mutate them properly, or these kind of things. So being very careful with that. And then my last point, I know I said that it was really clean code with a lot of interfaces and clear single responsibility and so on and so on. But that was my first disclaimer at the beginning of the video. It's not a beginner-friendly pattern, so make sure you have that diagram in mind, because that pattern has a lot of indirection and overhead to understand it. It's not simply that you're gonna store humans in a database and you're done. So it's not just one struct and then you just clumsily store them with another class. It's like it has clear responsibility between originator, caretakers, and memento. So be very careful on that. Alright folks, I hope you enjoyed that video, that pattern. So a little bit more complicated than usual, but hope you enjoyed it. If you did, like and subscribe so then I understand that you like this kind of videos, and happy coding!